Hi, welcome to a talk about HatCUP, hybrid analysis and attention-based just-in-time comment updating. My name is Hongquan Zhu, a master student from Nanjing University. When changing code, developers sometimes neglect updating the related comments, bringing inconsistent or outdated comments. These comments increase the cost of program understanding and significantly reduce software maintainability. Researchers have put forward some solutions which update comments efficiently for simple code changes, but are not good enough for complex ones. We propose HatCUP, which is a new mechanism for comment updating. In addition to the old comment tokens and changed code tokens, HatCUP considers more about the code structure change information. Finally, it gives the updated comment according to hybrid analysis. Our approach, HatCUP, consists of three phases: edit representation, model training, and comment updating. Specifically, for each code comment code change sample extracted from source code repositories, we first represent them as edit sequences. Then, our model is trained using the pre-processed data. Finally, given code edits, syntax changes, and the associated old comment, the trained model can automatically update the old comment to a new one. To better capture the potential code change information, we introduced a syntax change encoder together with a structure-guided attention mechanism. Additionally, we try to model the edit actions rather than generate comment sequences from scratch, defined as edit or non-edit mechanism. This figure describes the structure-guided attention. In this figure, a code change graph is created by analyzing the syntax change information provided by Gumtree Div. To efficiently generate comment fragments for modified parts of the code, we propose change-guided attention. We also constructed the data flow dependency graph and dependency-guided attention. The data flow supports the model in considering long-term dependencies. Different from the previous work, we do not generate a full new comment. Instead, we generate a series of edit actions to show how to update the old comment, called the edit or non-edit mechanism. Specifically, the decoder must determine how the source code changes will change the relevant path of the old comment. At each step, the decoder decides whether a new edit action should be executed by generating an action start keyword from insert, there, or update, and continues the current edit action by generating a comment token. It will not stop the current action until an action end keyword is generated. After the decoder gives us a series of edit actions, we could align it with the old comment and apply it to rebuild the updated comment. To evaluate HatCUP, we propose the following research questions, including the comparison with two state-of-the-art approaches, the effectiveness of the key components, and the efficiency in complex scenarios. We conducted our experiment on Ubuntu 18.04.6 with Int'l Xeon Gold 5118 CPU. We utilized one NVIDIA Tesla V100 GPU to train and evaluate our model. The model was implemented in Python 3.8 with PyTorch version 1.10.0. To evaluate the effectiveness of our proposed model, HatCUP, we evaluated and the baseline methods on the testing set in terms of various metrics. In general, considerable improvements are achieved by HatCUP over CUP in terms of all metrics. Compared to HatCUP, HatCUP performs much better on recall at 5 and outperforms it in AED and RED by substantial margins. This highlights that our approach can update comments more effectively and accurately than the baselines. To evaluate the effects of key components, we compare HatCUP with its two variants, HatCUP syntax and HatCUP edit. In summary, HatCUP significantly outperforms the two variants. These results demonstrate that the structure information and the edit or non-edit mechanism are helpful and valuable for this task. To evaluate the effectiveness of complex scenarios, we isolated instances from the test dataset that HatCUP could not handle. Then we evaluated HatCUP and the baselines on these samples. Results show that HatCUP significantly outperforms the two variants. Due to time limitations, we skip the discussion of related work. To summarize, we introduced a syntax change encoder together with a structure-guided attention mechanism to more fully utilize code structure change hints. And we proposed a new mechanism called edit or non-edit mechanism. The edit or non-edit mechanism generates a sequence of edit actions instead of directly generating a new comment sentence from scratch. We developed a new approach, HatCUP, for just-in-time comment updating based on the proposed idea and evaluate it on real-world projects. The evaluation results demonstrate that HatCUP can update comments efficiently. This concludes my talk. Thank you very much for listening.